Okay, so I have a student asking about the sample problem, I think sample problem 10.8. She asked about the problem on page 389, that I know. So let's look at this question here together. Page 389, I don't know if you can see that. Is calculate the concentration of hydronium ions for a solution of baking soda with a pH of 8.25. Okay? So we're looking for the hydronium ion concentration if the pH is 8.25. Alright, let me first of all do this the way that, I've done this as you would imagine a ton of times. And so I'm going to, first of all, do this with the formula. And I'm going to write out the formulas that I know, right here. pH is equal to minus log of the hydronium ion concentration, right? And the hydronium ion concentration is equal to 10 to the minus pH, which is just the inverse. These two equations are equivalent. All right, and I write these down. When I see a problem like this, I oftentimes don't know which one I want to use, so I automatically write both of them down. And knowing that, I look back at the question now and I realize I'm being asked that. Okay? So it says calculate the hydronium ion concentration. Calculate the hydronium ion concentration for a solution of baking soda with a pH of blank. All right. So I'm going to need this equation. It looks like. All right. So the hydronium ion concentration is equal to 10 to the minus pH, which is equal to 10 to the minus 8.25. Which is equal to, and I can't do that in my head. Of course not. Get my calculator. Use one that maybe look a little more familiar to you. Ten raised to the. Oh, you know what I'm going to do? Okay, first I'm going to say 10 raised to the minus 8.25. Enter. Okay? And that gives me 5.623 times 10 to the negative 9. Okay, let me do this another way. Instead of 10 to the negative 2.5, there's a button right here, which I don't know if you can see that. There's a button right here. It's the log button because that's the inverse function, you see. The 10 to the x is the inverse function of log, which is why they're together, which is also why I say these two equations are equivalent, right? The log, that's the common log. That's the common log, and there's the natural log, okay? The common log, the inverse function is 10 to the x. I don't know if you can see that on that video. But anyway, these are inverse functions. They're equivalent, right? You can see the hydronium ion concentrations in both of them and the pHs in both of them. All right. This is if I'm trying to solve for pH, then I use this one up here. If I'm trying to solve for that, I use this one over here. All right. So what I'm going to do this time is I'm going to say 10 to the minus pH, and this time I'm just going to put in here. Hopefully you can see this from where you are. 8.25 minus 8.25, right? And now I'm just going to press that button right there, the blue, right? So I've got to press blue first, boom. And then that button, boom. Oops. Sorry. Okay. That button will give me 10 to, right? Oh, you know what? It ends up being the same thing. I'm sorry, I'm not familiar with this calculator. So, if I either press those two buttons or if I use that button right there, which is the exponent button, okay, minus 8.25, enter, and it still gives me 5.623 times 10 to the negative 9. Okay, The last thing that I'm going to say about this is something I wouldn't make a big deal out of, but she does, and so let's go with the way that she says it. She'll be the standard, as always. She says that if there's two decimal points past, I'm sorry, 2 digits past the decimal point, then in our answer, we're going to say that there's 2 sig figs. Okay? There's 2 sig figs here. This then is going to be roughly equal to 5.6 times 10 to the negative 9. That's the concentration of hydronium ions in solution from page 389.